What is routing table and why do we need a routing table at all? Let me answer briefly and concisely. It is a table actually in each networking device, in each router there is a table based on which it makes decisions that which path to take for forwarding the data packet. So it is a table stored in layer 3 devices which lists all the routes, metrics and next hop. So basically it has three contents, three major portions. The first one is called as routing network ID. The second one is called as metric and third one is called as next hop. So what are these three? Network ID is the destination subnet. It tells us, okay, for example, if you have to reach to another city, the city name is Dubai. So Dubai is network ID which you have to reach actually. Maybe the postcode is 5002. So this one actually is your network ID, the destination which you want to reach. Metric is the path. It is the routing metric of the path through which the packet is to be sent. So this one tells us, okay, there are two routes. You can reach to Dubai via London. You can either go through Germany or either you can go through Spain or either you can take another route via Sudan, via Nigeria. So these are different metrics, different paths which you can take. So it will tell you the best path actually. And then the next hop, that which device. So after Dubai, where do you have to go to reach to Dubai? So this is called as next hop, the address of the next device through which it is only the next device. It does not tell you the whole route. It just tells you that okay, you have to reach to Dubai. So for example, from London, you have to reach to Dubai, right? So from London, which is the next station? Maybe after London, there may be another, maybe Amsterdam or some other city. So it will just tell you, okay, this is the next hop. It will just point. Once you reach to the next hop, there will be another next hop, which will be pointing to the next. So it is only the next destination, right? Let me show you the real routing table from a Cisco equipment, from a Cisco router. So whenever we run this command, show IP route, you can simulate this one in your packet tracer and GNS3. I have taken this output from GNS3. So which one says that how does the routing table look like? So this is the command I have run and it has given me some guideline in here. This is the guideline, just like the legend, it tells us what will be the meaning of C, what will be the meaning of S, O meaning will be OSPF. And this is the content actually of the routing table. This one tells us O means, as an example, O means that this is an OSPF route, right? 192.168 is the network which we have to reach. It is telling us that to reach this network, we can use a route which has been learned through OSPF, and the admin distance of that routing protocol is 110. Actually, we already know because we know OSPF will always be 110. Then this is important information. 2 is called as metric. So this metric tells us that what is the weightage, how much can we rely on this route, right? And then where this one. So this is your next hop through which you have to proceed, and this is the aging time. Let me show you the output and different parts. So I have highlighted for you. Here you can see that there are three parts mainly. One is network ID, admin distance and metric, and the next hop. There are many other parts, and in different vendors you will find a lot of other things, but these three parts will always be there. The first part says routing protocol, of course we know, and then but in the language of routing we have to find the routing protocol from here. So 110 means OSPF, 1 means static route, 0 means connected route, 90 means EIGRP. So from this number we can find, from this admin distance we can find which routing protocol is that, although it is written here, and then from the legend as well we can find this one, right? So you can see here. So this one tells us basically that to reach to this network, the admin distance, we have learned this protocol from OSPF, cost is 2, and this is the next hop which we have to follow, and this is the local interface which we can use, and this is the time. And then there is another information which is called as gateway of last resort. This one means that the default gateway, if you cannot find the route in here, for example, if you say, okay, I want to reach the network which is maybe 9.9.9.9. So this network is not here. It means to reach this network, you will have to send it to your default gateway. So if the router will start from here, it will try to look for that route 99999. No, it is not there. So finally, it will send to the default gateway. Default gateway or gateway of last resort. From the name you can see that the last resort means whenever you cannot find the route, then that packet will be sent to this one. Then it is up to the last resort or the gateway, what does it do with that route. So this is basically all about the routing table and how to read the routing table within a router. We need to go to the CLI and then run the relevant